Hi there and welcome to the chemistry lesson. In this one I would like to look at actually writing the equations. In the previous video I said I wanted to look at that, but I ended up looking only at how to write the molecular formula. So I would like to look at how do we write reaction equations. So before I get to that, let me just explain a little bit about what I mean when I say reaction equations. Well, a reaction equation or a reaction is what I call that event when two atoms or when two substances create a new molecule or a new substance that is different from the original one. Okay, so for example, and I've used this one a lot now, and that is the reaction between sodium. So we've got sodium, Na, and if it were to react with chlorine, okay, chlorine is Cl2, okay, then it will produce sodium chloride. Now let me just explain a little bit of the common questions that will come up here. Okay, first of all, why is it that chlorine has this little 2 at the bottom? In other words, the chlorine molecule or the chlorine substance, if I were to break up chlorine substance into the smallest part so that it's still chlorine, I will find that chlorine actually consists of 2 molecules like this, okay, where chlorine seems to be making a covalent bond. We've seen this before with hydrogen. We've seen that as well, that hydrogen, when it occurs in nature, occurs as H2. Why is that? Why does it occur like that? Well, first of all, these type of atoms or molecules are called diatomic. Diatomic, di refers to 2 atoms, okay, atomic. Diatomic is 2 atoms, and the reason why is because remember that all elements want to be noble. So in order to exist in a substance form, they need to have filled up their energy levels. Now sodium, on the other hand, actually has an extra electron, but because it is a metal, you might recall that sodium reacts with itself. Okay, it's an alkaline metal, reacts with itself, and it shares its extra electron among the whole sea of electrons in which the metal substance finds itself. Okay, but chlorine is not like that. It doesn't form a metallic compound, it doesn't share its electrons. It's got too many. It wants to hold on to its electrons. So what it ends up doing is it goes to another one. Remember, chlorine has 7 valence electrons. Okay, there's the 7 valence electrons, and he goes to another chlorine atom and says, okay, I'll share mine with you, please, I just don't want to lose them. Okay, so he goes and here's the 7 valence electrons for this molecule, and you can see now they are sharing these 2 here. I draw this very small, I hope you can see, but he shares one of his and he shares one of his, and so together they have filled out both of their highest energy levels. Okay, that is why chlorine itself is written as a diatomic molecule. All of the halogens, remember that is, these are the halogens. All of the group, what is this, group 7 elements are written as diatomic molecules, including hydrogen, and very interestingly enough, the one exception to all the metals, so all the metals are always written simply as sodium, potassium, zinc, copper, okay, all of them except mercury. Mercury also exists as a diatomic atom, molecule, which I find very interesting. But if you want to understand the reason, again, why all of these will be written as diatomic, well, it's for the same reason why chlorine is. All of them just need one more. That means that they have an odd number in their of electrons in their highest energy level. So one of their orbitals is missing or only has one electron, and that orbital will share his electron with the poor orbital in the other atom that also needs the extra electron. Okay, I don't know if you got what I'm saying there. I don't think it's that important, as long as you remember that all of group 7 elements are written as diatomic, as well as hydrogen. Oxygen as well. Okay, if we look at oxygen does the exact same thing, and the reason why oxygen does it, let me show it to you. Okay, if I have an oxygen atom, okay, if I had an oxygen atom, oxygen has 6 valence electrons, so it has 1, 2, let me rather write them here. So I've got 1, 2, 3, 4, and then there's 6. I'll draw the others just now, and then another oxygen, okay, has 1, 2, 3, 4, and now the other 2 in this one will both of them be shared, and the other 2 in this one will both of them be shared, so that if I were to finish drawing this atom, or if I were to just distinguish them, you will notice that I've got 1, 2, 3, 4, 5, 6, 7, 8 in this molecule. 1, 2, 3, 4, 5, 6, 7, 8 in this molecule. There I've got my covalent bond, and again, yes, I am working with a diatomic molecule. Okay, so there's a few that you will come to learn as you encounter which ones are diatomic molecules, and whenever I write them as a substance on their own, I have to write them as diatomic. Okay, now just to get back to my original equation, we were looking at this, we were asking why does chlorine have that little 2 at the bottom, and I explained it's because it is a diatomic molecule. Okay, the next question we already answered in the previous video is why do we have previous videos, I mean, why does this happen? And now a little bit more about this. On the right hand side we have what we call the reactants. Okay, it's almost like saying this is the ingredients to the recipe, the reactants. Okay, on the sorry, this is on the left hand side. On the right hand side we have the products. Now there can be more than just one product. Okay, in this case we only have one product. Okay, and the reactants produce the product. So I'm just giving these words so that in future videos when I use words you can follow me, you know what I mean when I talk about reactants. In this case the reactants is sodium and chlorine, and the product is sodium chloride. But I want you to notice a little problem here. Okay, let me draw the sodium atom on this side. So here I have a sodium atom, okay, and it is reacting with a diatomic chlorine molecule, and what happens now is that there is a break between these two, or this molecule breaks up, and one of these atoms bond to the sodium. Okay, I'm sure that makes sense, so that in the end I've got this. Okay, I've got that. This is exactly what sodium chlorine this represents. It represents one of these molecules. The problem is, however, what happened to the other chlorine? Okay, where did he go? And this is where we come to balancing equations. In order for this reaction to really occur, I need to have 2 sodiums. sorry, wrong color. I need two sodiums, and they're not diatomic molecules, they are two different atoms, okay, two separate atoms, to react with the chlorine, so that in the end, if I have two of these reacting with one molecule here, this molecule will split up. One of the chlorines will bond with one of the sodiums here, the other one will bond with the other one, so that afterwards I will have two of these, two sodium chloride molecules. Okay, so just in order, just so that our equation reflects this arithmetic property, okay, arithmetic property, I need to write it here. I need two sodiums to react with one diatomic chlorine to produce two sodium chloride molecules. Okay, now how would I have done this without actually having gone through drawing the pictures in order to understand it? Well, I'm going to give you some tips on how to do it, and then in the next video I will do a few examples ranging from easy to quite difficult. Okay, let me just first do another example to illustrate to you the problem. Okay, so I have hydrogen plus oxygen, and I told you just now that hydrogen is a diatomic molecule, oxygen is a diatomic molecule, and when they react they produce what is commonly known as water, or also common is its molecular formula H2O. Okay, so again, what happens here if I illustrate it graphically? Okay, I've got my diatomic oxygen, okay, and I have my diatomic hydrogen, okay, and these two diatomic molecules are broken up, and they end up producing an H2O molecule, which is a water molecule, an oxygen molecule, and two hydrogen molecules. Okay, so now we can see the problem again. We can again see, well, what happened to the other oxygen molecule? Well, that oxygen molecule is still there, and he also needs two more hydrogen molecules. So we have to have in the end that this extra molecule, atom, needs two hydrogen atoms as well to bond to him, which means we need in our reactants to have 4 hydrogen atoms, which means we need 2 sets of these, 2 sets of diatomic. So I will need 2 of these, which will give me 4 atoms, to react with one of these, since there's 2, to produce 2 of these molecules. Does that make sense? Okay, let me just draw this in as well. Okay, I need 2 of these. There we go. Okay, now how would I have done this without actually having drawn all these pictures? I think, considering the time that this video has gone on for, what I would rather do is look in the next video at the exact steps I would go through. So for now, hopefully you can see visually what the problem is, and in the next video I will try and show you an algebraic solution without having to draw the pictures. Okay, see you there.